Imagine a world millions of years in the future. A world where evolution has written a new chapter in the story of life. The world is inhabited by very strange creatures, like nothing the Earth has ever seen. 100 million years in the future, this vast plateau stretches for thousands of kilometers, with peaks of over 12,000 meters above sea level, higher than the Himalayas of today. It took millions of years to build this plateau. It was formed because the Earth's continents are sitting on huge plates that are moving very slowly across the face of the globe. And at some point, it's inevitable the continents will crash into each other, crunching up the land, creating mountains and high plateaus.
Well, much as India, by colliding into Asia in the present day, has created the Tibetan Plateau and the Himalayan mountain range as the largest and highest mountain range on the Earth, so too Australia, 100 million years in the future, in its northward journey is ultimately colliding with the southeastern portion of Asia, and indeed pushing up an equivalent to the Himalayas, except potentially even larger in extent.
Eventually, Australia collides with North America and Northern Asia as well, continuing to push up this vast plateau. On such a high plateau, the air is cold and thin, and snow covers the peaks all year round. Not a very inviting place for any creature. Yet every year, this bird migrates to the plateau, the great blue windrunner. A giant blue bird with a 3-meter wingspan. It spends its winters in the lowlands far to the south, but each summer it flies thousands of kilometers to reach this bleak, harsh plateau. And this is no ordinary bird. To soar at such a high altitude, the windrunner has 4 wings.
The bird we're going to find on this plateau is something completely different. At first it looks rather like birds you'd see today, birds you'd even see in the Himalayas today. But this one's special. It needs to go high up, and it's going to fly in very thin air because it's high altitude. The problem the bird has is how it can be efficient flying like that and yet also be able to take off and land, to dive down, to maneuver. All these difficult things. Birds today have exactly the same problems. They have to juggle being good fast flyers, good manoeuvring, perhaps good at escaping predators or catching their own food. And wings have to evolve within all these different constraints. Some birds have long wings, some have short, some have very pointed wings, some have very rounded wings. And the bird has to compromise the shape of the wings it has and the variety of types of flight it's going to use. future on this Himalayan plateau, these compromises have just got too difficult. You can't do it with wings built as they are now. So the windrunner's solution is to use the legs as well. Because it spends so much time in the air, it doesn't need to use its legs for running in the same way that modern birds have to. So it's turned them into a flight surface. When it flies with just the two wings, its four wings built of the arms, it's just like a modern bird. But when it swings its hind legs forwards, they become more wing. The surface goes up. And the result is it's much cheaper for the bird to fly. It can go further, it can go more slowly so it can see the ground better. This is a way of extending its design envelope. It's not restricted to just one type of thing, it can do a great deal more. Perhaps it's been forced to do this by the stress of living in a very extreme habitat.
The windrunner has a long neck, like a crane, and it's developed small winglets called canards to support its head during flight. With its back legs spread out, this amazing four-winged bird can soar for hours at a time in the thin air over the plateau. But up here, gliding above the mountaintops, the windrunner has another problem to face. And it solved that problem by colour.
The great blue windrunner is a strange powder blue colour. This bird is living on a very high plateau. High altitude means high level of ultraviolet light. That's both a threat and an opportunity for the bird.
Ultraviolet is invisible light off the blue end of the spectrum and is filtered out by the atmosphere. But in the thin air of the plateau, the bird relies on its special feathers to reflect the ultraviolet, giving the windrunner a strange blue fluorescence. All these special adaptations mean that the windrunners can visit the plateau every year to breed. Both parents feed the single chick, which can tell its parents apart, even though to us they look identical.
The main reason for the blue coloration of the great blue windrunner must be the protection from ultraviolet light, because without it that would be incredibly damaging. But these colour patterns give it another advantage. The animals can use the ultraviolet light to communicate signals to each other.
In ordinary light, windrunners look identical, but reflect ultraviolet differently. As they also see in ultraviolet, they can recognize each other by their unique patterns. Cold, thin air, ultraviolet radiation. This seems a harsh place to rear a chick. But there's a very good reason the windrunners come here to breed. A gigantic spider's web strung across a ravine 30 meters wide. In fact, there are hundreds of webs draped all over the valleys and ravines, spun by silver spiders. The spiders look silver because it's their way of protecting themselves from ultraviolet light by reflecting it. To make webs this big means working together as a group, something only a few spiders do today.
The social spiders that exist today tend to be species that build irregular webs that require a lot of silk. And one of the reasons we think that sociality may have evolved in those groups is because the silk is expensive, and individuals, by remaining together, they are able of saving on the amount of silk that each individual needs to invest to maintain the web.
Working together and combining their effort is one thing, but organizing themselves so they share out the work, division of labor, is something else.
The social spiders of today, one interesting feature of them is that they do not have any kind of division of labor. Everybody reproduces and everybody works. But a possibility is that in the future, spiders might have evolved some kind of division of labor.
In the future, silver spiders are divided into castes, depending on their age and size. They're larger than today's spiders, so the smallest and youngest, the line caster, has to start the web by floating across the ravine using a kite made of silk and floating seed heads. The line caster relies on luck and a fair wind to float to the other side, where it attaches the line to the rock. Once the first line is secured, another caste, the bigger web builders, arrive. They venture out onto the first lines, spinning behind them stronger tether lines that will make up the framework of the web. After that, individual spiders spin webs to fill in the gaps. But unlike the webs of today, which are designed to catch insects, these huge structures are designed to trap seeds. Seeds of the grass tree. Grass trees are descended from bamboos, and every summer, for a few weeks, they fill the air with their seeds. Their tough woody stems are strong enough to withstand the wind, and the grass trees use the wind to their advantage, just like grasses of today.
Well, modern grasses are largely distributed by wind. They simply create huge amounts of seeds, and these are blown. Sometimes these may also be trapped on the surface of animals, such as when they become trapped on the surface of your trousers or your socks. They may be eaten or carried around by small animals, but it's a very unspecialized dispersal system.
It's not just grasses that use the wind to disperse their seeds. Dandelion seeds are carried on the wind by elaborate parachutes, taking them miles away from the parent plants. In the future, the grass trees have evolved large parachutes to carry their seeds.
So what we have imagined for 100 million years in the future is that the dispersal system remains relatively unspecialized, and that frequently they are blown in great clouds through the air. But instead of just landing somewhere on the ground and germinating or being picked up then by some little animal that walks off of them, what we're envisioning is that somebody has taken advantage, as it were, of this bounty that is blowing through the air mass. And this is a spider which is making a very large web that is catching and trapping not insects, but the seeds of the bamboos.
During the summer, as many as 100,000 seeds a day are caught in the silver spider's great web. Worker spiders spend all their daylight hours collecting the seeds and ferrying them into crevices on the sides of the ravine. These deep crevices have been eroded by wind and rain and provide a secure home for the spider colony, and somewhere to store their annual harvest of grass tree seeds. Silver spiders live in a very efficient society. Different castes do different jobs, and the whole system is held together by a central figure, the huge, bloated queen. She is the only spider to breed. The other spiders tend to her every need. All the queen has to do is lay eggs. Despite all these spiders, the crevices also shelter a small, shy rodent. A poggle, the very last of the mammals.
It's 100 million years in the future and most mammals have now gone extinct. One of the few mammals that's left is a small hamster-like rodent that's probably evolved from a social rat. Even today, the mammals are doing badly. Many species are going extinct, and over the next few 100,000 years, we're going to lose most of the diversity of the mammals we have today. All that's likely to survive are some of the more successful groups, such as the rodents. And even then, they're not going to have the competitive advantage they've got today, because as the world warms up, other species will adapt and expand, and the advantage that mammals have will become less and less. So within 100 million years or so, they'll virtually be on the point of extinction.
The poggle is the last mammal ever. All the rest have died out. These last mammals spend all their lives in a dark cave at the mercy of a colony of spiders. Yet most of the time, the poggles seem to be ignored by the spiders, hiding in the shadows and snatching seeds when they can. It seems strange that, having gone to all the trouble to collect the seeds, the spiders just let the poggles help themselves. But it isn't always like this. Just sometimes, the spiders seem to change their minds and attack. Then the poggle is dragged away to be eaten. In fact, the spiders are farming the poggles, feeding them seeds to fatten them up for the slaughter.
The spiders get two things from feeding the poggles. The poggles are very prolific and they produce lots of youngsters. And so some of the youngsters are actually eaten by the spiders and they're a food source.
The poggles are the spiders' only food source. The spiders collect their rich harvest of grass seeds, and the poggles convert them into flesh. But there's another more sinister reason for the spiders to farm poggles. The queen.
The queen spider feeds on the blood of the female breeding puggle because the hormones produced by the puggle actually stimulate the reproductive system of the queen spider.
So one question we may ask is why these spiders have developed this complicated relationship with these mammals. They first collect the seeds to feed the mammals. Why don't they just eat the seeds? And the reason for that may be because they have not been able to change their habits from being carnivorous, feeding on insects, to feeding on plants. The way spiders feed, they paralyze an insect and then inject chemicals, these enzymes that will digest the insects, and then they suck up the juices out of these digested insects. So their mouth parts are specialized for this kind of activity. And they may not have been able to change their mouth parts, their sort of feeding apparatus, to chew on plants the way it would be required to feed on plants instead of on these pre-digested insects. But another possibility is that in order for these queen casts to develop, that is, these individuals that lay the eggs and reproduce, they may have perhaps used some of the chemicals that they get from the Poggles to perhaps control and suppress the reproduction of other members of the colony. So in that sense, the spiders would depend on the Poggles both for food and for developing of these queen hormones. And at the same time, the Poggles would depend on the spiders for a collection of seeds. And that way they would have developed a relationship that makes them dependent on each other.
The spiders thrive on their diet of Poggles, and so many spiders are a feast for the windrunners. This is why they fly all this way to breed. Up on the high plateau, with plenty of spiders to eat and no predators, life seems safe for the windrunner family. But the Great Plateau is still moving, still restless, and at times shaken by earthquakes. And sometimes the earthquakes are more serious. It isn't just the plateau that's restless. Now it's the whole planet.
Million years in the future, we've entered a period of increasing volcanism, and initially what this did was led to a greenhouse effect. CO2, carbon dioxide, built up in the atmosphere and led to a global warming, and in that in turn created a proliferation of life. But volcanoes have their downside as well as their good side. They can lead to global warming, but in sufficient quantity with enough explosions and enough massive distribution of volcanoes, they can start to emit a large quantity of other things as well. Sulfur, perhaps, is one of the most common. This can lead to an acidification of the atmosphere, of the oceans, and ultimately to a mass extinction.
A mass extinction is a worldwide disaster. A time when whole groups of animals disappear and the majority of life on Earth goes extinct. Food chains are broken, whole ecosystems collapse, and life teeters on the brink of annihilation. The world's climate changes dramatically, and very few creatures will be able to survive. Many of the specialized creatures, like the great blue windrunner and the silver spider, are doomed. Mass extinctions have happened before in the history of life on Earth. What, if anything, can survive a mass extinction of the future?